Good morning, everybody, and welcome. I'm Ellen Fay, Director of the Sustainable Soils Alliance and co-lead of the Land Use for Net Zero, Nature and People Soil Health and Carbon Dynamics Topic Advisory Group, which is very much longhand for the LUNS Soil Tag. I co-lead the Soil Tag alongside Professor Pete Smith of the University of Aberdeen, and I'm pleased to be chairing this morning's workshop alongside my SSA co-director, Matthew Orman. But first, a bit of background. The Soils Tag is part of the wider LUNS Hub, a UKRI-funded research initiative working to help deliver climate and nature goals through land use transformation. Our tag has 4 priority objectives, which are to collate evidence reviews on soil health and carbon dynamics, to lead workshops that define healthy soil systems, to assess new and novel indicators, and finally, to analyse the landscape of soil monitoring tools and technologies. As part of this work, we look to identify and drill into specific, especially emerging topics that the soil community raise with us, where they would benefit from expertise, insights, and to learn from the experiences of others. So one such example is soil carbon baselining, which is the subject of today's event. And we're delighted and very grateful to have knowledgeable speakers here today to talk us through the issues from their expert, practitioner, and very practical perspectives. We're also very grateful to have a diverse audience from farmers, policymakers, and corporates to researchers and land managers. This demonstrates the range of interests in the subject. So please, everybody, think of yourselves not just as silent participants, but we're really hoping that everybody here today will contribute to the discussions with questions, experiences, and the challenges that you might face, both in the chat and the Q&A at the end, all of which will be captured in the output and uploaded to the LUNS website, where we hope people will be able to make use of it. So can we have the agenda, please, Zach? Thank you. As I say, one of the challenges raised with us most regularly, both in the Soils Tag and at the SSA through our industry platform that we run, is around this question of soil carbon baselining. Questions come from a variety of stakeholders. They're motivated by different but overlapping objectives. For example, from corporates to feed into their carbon inventories and to quantify the impact of their interventions, from governments to see the direction of travel for one of the pillars of the environment, which is obviously soil and carbon generally, and for which there are different targets in place. From landowners engaging in carbon and nature markets, and from farmers looking to understand the state of their most important asset and to satisfy the needs very often of some of the stakeholders I've just mentioned already. Despite these different objectives and different contexts, these stakeholders raise with us some similar challenges and questions. They are top of mind. What does high integrity look like? What is the standard protocol for baselining soil carbon? Number of samples, depth, frequency, etc. What additional in situ or spatial data should I record to make the exercise useful going into the future? How much should I invest to ensure I'm not stranded with unusable data further down the line? And is there an approach that is unique to my specific context? So today we'll hear case studies from a range of organisations working at different scales, using different technologies and methodologies for different outcomes. They've had to answer some of those questions that I've just mentioned as they develop their own soil carbon baselining initiatives. So we're going to hear from Helena Black from AgriCarbon, from Tom White from Yo Valley, from Felicity Roos from the National Trust, and from John Gilliland, who is going to talk about his experience at Arc Zero and also about the Soil Nutrient Health Scheme. And John's kindly also offered to cover for Chris Gooderham, who has been called away. But John was very involved in the AHDB experience of developing that national baselining pilot. And finally, we'll hear from William Blake from the University of Plymouth, who does a lot in this space and is also part of the LUNS project, which is separate from the hub, called Open Land. So to kick off, each speaker has been asked to give us a brief 5 to 10 minute presentation, and hopefully we can stick within those parameters, outlining their overall baselining approach, the technologies, protocols, or sampling regimes used, the scale of investment level, and their key motivation and intended outcome, be it soil stock change tracking, corporate reporting, or readiness for carbon market participation. And of course, what they feel they've learned through their experiences. So enough from me. At the end, of course, we'll open up the floor, as I said, and hopefully we'll get an interesting discussion going. I hope everybody has something to contribute. So over to you, Helena, as our first speaker. And Zach will be managing the slides. So do just ask Zach to go on to the next slide when you're ready.
Perfect. Thank you. Morning, everybody. Nice to see some familiar faces here. I'm Helena Black. I'm Chief Scientist at AgriCarbon, and I'm here to give you a flavour about baselining soil carbon from a practitioner's experience. You're going to hear from others later on that have actually applied some of the techniques and approaches that I'm going to discuss shortly. Next slide, please. I'm going to set the context of why I'm here talking to you today. I work for a company called AgriCarbon that started in 2020, and since 2021 collected over 500,000 soil samples from more than 18 countries, more than 25,000 fields, from more than 250,000 data points, mainly in UK and Europe, but also increasing US and Latin America. So amassed a huge data set, which has allowed us to look at some of the questions that Ellie's actually mentioned earlier on. And just to illustrate this, I think in terms of what we're dealing with baselining soil carbon, we're talking about a wide range of mix of land uses, arable, grass, mixed farming, other, including things like rewilding. And we're talking about working with organisations across a very diverse field, from food and beverage companies, project developers, and a range of different landowners. So it's a very diverse landscape that we're operating in. And I'm going to say right now, there is no one size fits all here. It's all about trying to adapt methodologies and approaches to fit individual clients' and customers' needs. And the one thing that I did put at the end there, you can see I've put soil carbon percentage, fine fraction bulk density, and soil mass. I just wanted to reinforce that we're about baselining soil carbon stocks. That means we need to measure these three properties at scale and at a cost that people can afford. And I just illustrate, not using AgriCarbon numbers per se, but if you could imagine that it was £10 a soil sample, over 500,000 soil samples have been collected in the last 2.5 years. That gives you an indication of the scale and investment in this area. Next slide, please. Oh, there we go. Next one. The next one's about the typical stages. Oh dear, we're having a bit of a flick around this morning. Apologies. When we get to the slide, really what I want to talk you through is the typical stages of baselining a soil carbon project from an AgriCarbon perspective. Nobody really wants to see typical stages, obviously. I'll talk through it while we try and get to that slide. There's, as we see it, 6 stages. Before you even get in the field and collect a single soil sample, it's critical to understand certain things about a project and about what they're trying to accomplish. And the first one is about how the data are going to be used in reporting. What is the aim of the data? Is it for Scope 3 reporting? Is it for voluntary carbon markets? If this is the case, then there will already be guidance or rules around how you calculate your stocks, what laboratory analysis you can do, what field sampling, what your sampling design is. So it's very important to start from that point of view. How are the data going to be reported? And that also dictates other things like, is it going to be inventory reporting? That means you starting from T naught and looking at change over time from that starting point. Is it going to be intervention reporting? You mean you want to understand the change associated with an individual farming practice or change in practices. That also dictates whether the sampling is to monitor individual management practices or a project scale as an entity. And that has massive implications for your sampling intensity, your sampling design, and ultimately the cost to a project. The other thing about your reporting is, and this is often skipped over because we assume we were just going to measure and remeasure in the soil sampling point of view. Our project's using a model to quantify their emissions reductions and removals. And most projects are. And if they are, again, that has significant implications for what it is we need to sample, how we sample, and how frequently we sample. So the point here is that sampling is primarily to feed into a model and not necessarily for detecting change on the ground. And we might want to come back to that point in the discussion. I think you're at my next slide here. Now, I'm not going to spend a lot of time on this slide because you're obviously going to hear from some of these colleagues later on about the specifics of these projects. But the thing that I really wanted to emphasize for what we're having to deal with, we're looking at designing baselining that will work at a farm scale, might work at a cohort of farms, it might work at a region, it might work at a country. And there are many different protocols and methodologies out there. As you can see from the little white box, you've got Vera, you've got IPCC, you've got the greenhouse gas protocol. For us, those of us operating in this field, although I said there is no one size fits all, and the protocols are always changing, there is one fundamental thing I think I've come across with people. We're all trying to establish something that would allow us to be comparable and intercomparable. And that means trying to develop methodologies so there's a degree of consistency. And so from an agricarbon point of view, we often use the Vera protocol VM0042 or 32 across both Scope 3 reporting and voluntary carbon market reporting. And it's not simply because there's not as yet a soil carbon removals protocol for Scope 3, but also there is this drive to try and harmonise and be consistent. So I think I'm mentioning it now because I think it's important from the scientific community to try and help establish that consistency and harmonisation. And I'm going to say something now that's a request, please, people. For those of you that are familiar with Vera and VM0042, it's currently in revision and it's about to release a draft of a soil sampling handbook. And I think it's critically important that this community engages and feeds back whether they think what's being proposed is practical, feasible, doable, affordable. So a call out to keep an eye out for that when it comes out, please. Next slide, please. You asked me, oh, we're really having problems with, there we go. So the bottom of my 6 stages, when you get to see it, is the scope of the project. And it's almost always driven by a fundamental question that says, how many samples do we need? Because how many samples do we need reflects the cost of a project. And that number of samples is not just about your laboratory analysis. It's also about the logistics of getting to a field. It's about the design stage. And just a little reminder, the vast majority of costs associated with a project is getting to the field, not the lab analysis. But I've put this value box in here because I think you also have to be aware of those that are paying for these projects also see value to them. And it's understanding what that value is helps to balance the cost of a project. I'm going to move on to the next slide, please, because I know I don't want to run over time. Thank you. So how much does it cost? This just serves to illustrate that there is no one price for every project. It very much depends on the scale. A smaller project will tend to be more expensive than something a very large landscape scale, say tens of thousands of hectares. And the reason why is that you do not need a great deal more samples at a landscape scale to detect change than what you do at a farm scale. We use something called the minimal detectable difference to look at this. You can ask me about that later. Next slide, please. Keep going. Right, only 2 more slides to go. So ultimately, when we're talking about self-sampling, I've mentioned we have to look at scale of reporting, we have to look at the sectors where it's arable pasture, etc. We need to consider things about sampling and reporting depth. Most projects will be reporting at 0 to 30 centimetres, but there's a question about should we go deeper, how do we deal with equivalent soil mass, etc. I think a key role for the scientific community is actually helping guide projects and what the expected change and variation around that is, because that helps to refine sampling strategies. And I think there's a really big knowledge gap about what is the expected change under regenerative agriculture, or dare I say rotations, and how you attribute change. Sampling design is obviously a key thing in terms of the sample number for a project, because you can refine that by optimizing your sampling design. But the bit that I really wanted to emphasize here is, if a project is using a model and measure approach from its quantification, then the critical thing in establishing sample number is how much uncertainty is associated with that model, and what uncertainty deductions will be made when determining how many carbon units are generated. And that then reflects also the value to the project. And we really do need to spend an awful lot more time on those uncertainty calculations, and not just how many tons of CO2 we think we're generating. Last slide. I think the key focus here is always about what is the confidence and the outcomes. And I think across the piece, we all are trying to increase the confidence, the outcomes from carbon projects. And I'm not going to dwell on this. The one thing that I'm going to emphasize, there's two things I'm going to emphasize, I think that the scientific community can really help with. And one is about quality management, verification and audits. There's a lack of expertise out there to be able to audit and verify projects, particularly in the modelling community, but equally about how do we set up quality management that's going to be monitoring change over 5 to 10 years. My key bugbear is soil archives in that sphere, and no protocol actually says keep a soil archive yet. Watch this space. And as I've mentioned already, what we need is much better evidence base in the scientific community about what will be happening under regenerative agriculture. And I'll leave it there because I'm critically aware I've gone over time.
Thanks so much, Helena. That was brilliantly clear. Sorry about the glitch in the slides. We'll make all the slides available afterwards so we can get back to that. That's brilliant. Thank you. We're going to skip on to Tom now from Yo Valley. Any questions to Helena, do pop them in the chat now, but also don't forget we'll have time at the end for questions, sort of live questions. So thanks.
Hello, everybody. Can you hear me? Great. Hi, I'm Tom White. My job title is the Regen Farming Manager at Yo Valley, which is the title that covers kind of a multitude of sins, and it essentially sees me working a part of the time on baselining and data across lots of different areas, but a big focus of that over a number of years now has been on soil carbon, working with our farmer suppliers to kind of think about, not only are we measuring it, but what are we going to do about it, and then engaging particularly with our retailer customers, but also with lots and lots of stakeholders externally who are interested in the same things as we are. And I think I was just reflecting as Ellie was starting that despite having looked at this for quite a long time, I still have many of the questions which seem to be on that FAQ list. And so what I thought I'd do is just talk a little bit about what we've done over a number of years and where we've got to, and it by no means is the end of the story, which is why I called this the story so far. If you could skip on, conscious of the pace that I need to go here, but I thought I'd give a little bit of context of Yo Valley. So we're a food and farming business based in the West Country. We have an organic brand that's relatively well known for making yogurt, but is stretching into other food areas, which allows us to encompass more of a kind of regenerative farming system and the outputs of that. And that's been kind of a journey that's been running alongside our thinking about soil, how we farm, the impacts that we have, and all those kind of things. And we're very lucky as a farming business, as a food manufacturing business, to also have our own farm. Whilst we have quite a big farm supply chain, we have a 2,000-acre farm in North Somerset where we can try things out, and often what we're working on starts there and expands outwards. Next slide, please. And our very basic stated purpose now is to nurture and nourish people and planet by making great food the right way forever. And soil carbon baselining kind of sits probably not at the front of the marketing material from that, but very, very importantly in the background under the bonnet. Next slide, please. I'll skip past this because I'm worried I've put too many slides in. So a little bit of background. As far back as sort of 2015, we started to look at soil organic matter as a new thing that was kind of being talked about to us, that started to appear on lists of options for soil samples that you were sending off for something that you could get back. And we had a look and reflected on some of what was being said about perhaps regen agriculture overseas and organic agriculture. And so we started to look at our own farm in a literally very shallow way in the kind of 0 to 15 centimeter zone. And I think we've quickly started to understand, some of the massive uncertainty, which I think lots of people come across quite quickly, which lead them probably to Ellen's door to ask what should we do and how. In that, in the UK, we have this amazing level of variation, very kind of patchy, difficult to access or non-existent historical data, and a lot of head scratching and kind of disagreement about how we go forwards. Next slide, please. So what we did essentially, that after having thought about it for a couple of years, was what seemed like a very big piece of the work at the time, and now feels like a very, very tiny piece of work, which was to start on our own farms, on our 2,000 acres in Somerset, and to bring in Farm Carbon Toolkit, because this was a year or two before AgriCarbon even existed, and to start doing work down to 50 centimeters, and doing it in quite a kind of high resolution way, working within every field, and taking samples for loss on ignition. And that gave us some really interesting initial findings. And I think now looking back, we kind of reflect that's all that they really were. They were initial insights, just a peek under the soil surface. And what we saw was that across our farm, which is quite a big mixed farm, but in a relatively close geography, we even had a huge variation in what was going on. We have 4 or 5 major soil type changes across the farms, but we have fields next door to one another with very similar management, with quite different soil kind of values. But what it really encouraged us was that, being a farm that had been under organic management for 25 years at that point, we had pretty good numbers, in comparison to some places, and that we felt like that variation, in a sense, gave that encouragement that if we have that potential on some fields, then the art of the possible is to look at the practices and approaches which can pull the socks up on the other fields, and that really was our quite simple starting point. Next slide, please. Sorry, and I mentioned this, but alongside doing carbon and bulk density measurements, we also carried out some nutrient analysis, and I think really importantly, the soil health observations. So looking at structure, worm counts, infiltration, and soil aggregate stability tests, brings really useful color to whatever you're doing. And I think in many senses, but for the accounting piece of this whole discussion, those things can be more useful for engaging farmers in what you're going to do, and what they might prioritize in their management than a flat carbon number, which might not change for a 5-year time horizon. Next slide, please. So what we did then was kind of think, well, our farm is great, and we have some resource to be able to experiment and play around, and we'd been doing that for a long time. But were we typical? What was the state of the supply chain more broadly? So that project grew then to looking at 25 farms in our network. Most of them, almost all of them, were organic dairies. There was a couple of other different land uses and things in there, but to have a broader look basically. So 2021 to 2023, we dug lots and lots of holes. This was all work that was carried out very manually. And as Helena was saying, a huge part of this process is the logistics. A huge amount of the cost goes into the ability to get to the farm, get soil out of the ground, and get it back to the laboratory for analysis. And so this project, 25 farms and 16,000 acres, was no mean feat. It was carried out manually with buckets and hand augers and spades, and gave us again some really interesting insights. Some encouraging baseline information about the state of organic dairies in the West Country, some of which we might have expected as being organic farmers. We're full of hope and enthusiasm for our approaches to farming, and I think some of that was borne out, but certainly, again, huge variation. But some really good leading kind of insights again on some of the practices some farms were using, the use of deep rooting species and diverse swards, grazing strategies, and organic management generally. Skip on, please. So as we were coming to the end of that piece of work, and we were thinking a lot about it, as a pilot and as a limited 25 farm kind of thing, one of the kind of most fundamental pieces of literature, one of the biggest impacts on our thinking, kind of landed on our desk late 2022, and we were asked to work within the pilot of the land sector removals guidance draft in early 2023, and I guess that was it's a lengthy and very technical document, which I can't, I wouldn't attempt to summarize for people here who probably know much more about it than me. But for us, it was a first glimpse at an opportunity to put soil carbon removals into the mix. It seemed like the door opening for the first time, and it by no means tells you how to do it. But I think its basic tenet is, if you want to use soil carbon removals at some point within a farm carbon footprint, you will need a very, very high level of statistical certainty to do that. That was essentially our take home. And we're still I couldn't believe it was 2022 actually when I went to write this, because I believe it may now have been pushed back to 2026 before it's going to actually come in. And I don't know what changes will happen between the draft and what lands, but essentially we've used this quite a bit as the best information we have about what a supply chain might need to do to produce a Scope 3 declaration. Next slide, please. So alongside sort of thinking about the LSRG and what it was asking of us as a kind of a bar to pass, we were also coming to the end of having done that work with 25 organic farms. And what we realized was that really supply chains are going to have to change if businesses the supply chain from the top to the bottom with all the actors within it are going to look at this stuff and try to track soil carbon and monitor it. The relationships are going to have to change somewhat. So not just for this reason, but because we believe we're going to have to get much closer to farms to do the level of engagement and knowledge sharing work that needs to happen. We're going to need to pay farms differently to ask them to change practices. And we're going to need to share a lot more data in both directions, actually, about what works and what doesn't. And obviously the soil carbon data is a really important piece of that. That kind of catalyzed us to make some major changes to our supply chain, which meant setting up new farmer groups, so recruiting farms into new agreements with us to supply milk and in the future probably other foodstuffs, where we could have that two-way street of discussion, where we could get together and look at what was influencing the data, and where we agreed to share the data with one another, where we agreed to make the investment to go onto farm and take the data, and the farms kind of knew the what and the why of us doing that. So we now have, as we move into this year and last year, we have new relationships with farms. We have essentially the LSRG and the idea that we probably need very, very high statistical power to be able to utilize soil carbon removals at any point. And that brings us up to the next slide, please. So going forwards, we are, and Helena touched a bit on how AgriCarbon do this, but we're going to work with AgriCarbon, and we're going to roll out soil carbon monitoring across essentially our whole supply chain. That will take a long time. That will take us down to 1 meter's depth, and we are at the moment looking at doing that on a very, very high level of resolution, I guess, down to a 0.5 ton minimum detectable difference on an annualized basis, which I will certainly let Helena explain later. But looking very closely and trying to sense fairly small changes.
Post.
Is our program going forwards, and it's going to take some years for that to obviously roll out across the whole supply chain, but that is essentially the decision we have made off the back of what we've learned, and the LSRG, which brings us up to essentially to date. Could I see the next slide, please? Yeah, okay, so just some brief summings up, really. I think I'm probably over time. I said this was the story so far. I don't think any of this stuff is bottomed out yet. I think we'll continue to, incorporate what regulation says, or what standards say about how we should do this stuff. I think we'll continue to look at the technology and the approaches to getting soil out of the ground. I firmly believe at the moment that is what we have to do, and that remote sensing is a long way off of being able to really kind of take over from old-fashioned soil cores. It may happen in the future, and I think we kind of find ourselves at the point now where we are potentially overdoing it with the level of data that we are doing, but we feel like that's the most risk-averse approach with the uncertainty that we have now about the data that we might need in the future. I think in the future we may be able to come back slightly from the level of intensity of sampling and cost that we are undertaking here, and that perhaps, whilst as I say, we very much believe that measuring, getting soil through the labs, and doing this stuff properly is the way to go at the moment. I think that modelling will need to come in the future to inform, the years between 5-year sampling intervals, and to help us, basically interpret the results without completely removing the requirement to go on farm and get soil out of the ground. I think my last slide is the next one. So yeah, just a few thoughts and challenges. We firmly believe that the benefits to carbon stocks, if there are any, and we probably need to think very much about how we dial those practices up, which we think are positive, and reduce those which we think are negative. But if there is an increase in carbon stock in soil, we think that benefit should sit firmly with the food that's being produced. I think that carbon credits and the selling of carbon off of farms at the moment is a very dangerous place to be for farms and for food production. These points on this slide don't necessarily relate to one another. There is a huge cost to doing what we are currently doing. As I said, we felt like the first bit of work we did on our own farms was a massive piece of work, and we've now done another 25 farms this year, and we'll probably be rolling on and doing that number of farms to a much higher level every year for the foreseeable. Ellen mentioned in her kind of list of questions whether we had a focus on other benefits that might come out of this work, and we absolutely do. I think this is a specific question about carbon baselining, but everything that we do in engaging farms and utilizing the results that come from this work when we engage farmers, put advisors on farms, run events, is around bringing practice change that will absolutely enhance biodiversity, water, nutritional health. And one of the things which we get very powerfully at the moment, so I've included it here, is farmer enjoyment of what they're doing. this whole piece of work, which we started really by peeking under the soils on our own farm and led to, projects and now supply chain kind of frameworks around regenerative and organic farming practice, seems to come often with a huge amount of enthusiasm from farmers about contributing to solutions. So I think that that's definitely a huge co-benefit of all of this work for us. And I just have to put on there really that the continuing uncertainty about how and when we utilize data that we have about soil to bring it to bear on carbon footprints. That uncertainty continues to hold up progress, and we're doing everything that we can. There's a massively kind of scattered approach across the farming industry of levels of engagement and work being done because there's so little certainty really about how to get about it. Okay, that's it for me, I think.
Thanks so much, Tom. That's fascinating. And it's really good actually to have that that perspective, both from the farming perspective and then also from the kind of producer and supply. So you're in a really sweet spot for us because you've got that inside view, looking out to all of those strands that are just so critical in this whole space. Yeah, thanks so much, Tom. That was brilliant. And so we will skip on to Felicity from the National Trust. I can't see you for a second, Felicity, but onto your slides, which Zach will share. You just let Zach know to skip on when you're ready.
Yeah, I am here. Can you hear me?
A little bit glitchy for me. I don't know if it's glitchy for others.
I will try. My internet's been in and out the last 2 days, unfortunately.
Yeah, do feel free to come off if you need to.
Yeah. So there was a background for those who don't know the National Trust. We are a large charity. So the National Trust covering England, Wales and Northern Ireland. National Trust Scotland is separate. We have around 250,000 hectares of land with around, depending slightly on how we count them, 1,800 farm tenants. So most of our farm land is tenanted, but we have about 50,000 hectares, I think it is at the moment, that's managed in hand. So our approach to soil sampling, we've been collecting soil data for quite a few years. And if you dig back into the archives, we have handwritten paper records stored in filing cabinets, which are very useful, I'm sure, if someone ever digitizes them. And sort of the last 10 years up to 2025, we had a strategy focusing around people and nature and carbon, in which we monitor soils very much in a sort of subjective way, in that the scoring was based on people's perceptions of soil health. So it was very much looking at surface condition. And it was only sort of going into COVID in the last 5 years, we started to shift to think that actually we need a much more data-based approach to not only soil health, but just general nature in general. And so this is where we developed our sampling strategy, which is fairly ad hoc in that we do it largely when stewardship agreements require it, or as a part of baselining for a project, which is generally externally funded, because our greatest challenge is the financial cost of sampling. We would love to set up a national sampling strategy where we sort of capture all of our land uses and all the variations of soil types across all of our land. That's just not an option at the moment. So we have an internal sort of methodology which describes what samples, how sampling should be done, what samples should be sent off for analysis, and how the data is recorded to try and introduce some consistency, because a lot of those historic data sets we've got are very handy, but everyone at Property sort of did what they were interested in. So there's very little uniformity in our historical data. We use the same lab. We selected NRM just because they gave us the best sort of price to try and reduce variability in the data. And all our data is currently stored in an ArcGIS layer, which is practical in some sense, but not very useful in terms of analysing the data and design and our strategy sort of going forward of how we manage it. So our next slide, please. Yeah. So our methodology is to use 3 fixed GPS sampling points within the field or area we're sampling. We sort of shifted to this away from the traditional Walker W approach because we're not always sampling fields. We might be sampling areas of heath another habitat, and so walking the double can be a challenge. But also it means that going back and future monitoring, it's much easier to go back, hopefully, to basically the same point with a couple of meters error, which will hopefully, with repeat sampling, reduce some of the variability that might come for just walking a different W, particularly if you're not in a sort of traditional field environment. We do all our sampling across all habitats, whether it's agricultural, arable grassland, native habitat, to 15 centimetres, which is spade depth. This is because very few people in the National Trust own an auger, but basically everyone has access to a spade. So we're trying to come up with something that was simple for everyone to do, for all staff to be able to do and have the resources to hand to do it. I measured a whole load of spades in a garden centre once, and they all vary between 15 to 17 centimetres. So it's a fairly consistent depth if you just say spade depth to everyone. We sort of say that whenever you're doing any sampling, you must do VES, so the visualization of soil structure and earthworms, to give that good indication of soil structure and sort of biological health as best we can, because for a lot of our habitats and locations, we're not interested in that sort of agricultural production soil fertility aspect. That is a sort of a side aspect. We're more interested in the general soil health, and we figure these are two cheapest and most accessible means of getting a picture of what is general soil health. In terms of lab samples, we tend to either do NOMs A218, which is sand agricultural plus organic matter. So that's pH available, pKmg, and organic matter through loss or ignition. Or where we've got projects generally externally funded that are interested in soil carbon, we do NOMs carbon check, which they calculate bulk density remotely and then do inorganic carbon, organic carbon, total organic carbon, soil organic matter, carbon nitrogen ratio, total nitrogen, I think, and I've possibly forgotten something else there. But they give you a tons per hectare figure as well at the end. Next slide, I think. So the greatest challenge, which I think, as Tom has suggested as well, is the cost. It is time. It is labour expensive, and the lab costs add up quite quickly, particularly if you're sampling at scale for a charity that, we don't necessarily see return on investment in this, which is why a lot of our sampling is done linked to externally funded projects. So we have areas of our land which we have quite a bit of data for, and then we've got large areas where we don't have data, and linked to some of the projects we've been involved in, we've got perhaps some habitats and land uses that are now overrepresented in our data. So in terms of having a sort of a good understanding of soil health and soil condition across all of the National Trust, we've got challenges around doing that. Recently, we found that a lot of the funders we've worked with have not provided clear guidance on what they want in terms of soil data. So we've got a couple of landscape recovery projects which just have a line in saying record soil health or monitor soil health, and that's it. And when you've got a 10,000 hectare project across the Yorkshire Dales with everything from peat to sort of chalk grasslands around Madam Tarn, it's a slight challenge on what do they want, what do they want the data to say from that? And we've had the same with private funders as well. So we've had HSBC funding for tree planting, in that because they're interested in carbon and tree planting, they wanted us to do some soil carbon monitoring to show the impact of planting trees. And again, when we asked them, well, how confident do you want to be in the results that the tree plantings reduce soil carbon? They couldn't answer. So we basically discussed budgets. So with HSBC, so how much were they willing to put towards monitoring? I was like, well, okay, we'll use that to design the best sampling strategy we can to answer, is tree planting benefiting soil carbon for the budget available? And the landscape recovery again, so using the Yorkshire Dales example, we had about, from the budget available, there's about £10,000 or slightly more to spend on soil sampling. So that's split. Basically, we're spending about £5,000 of soil samples. We're spending 5,000 or 6,000 on a contractor to do all the soil sampling. And that poor contractor is going to be so fit by the end of it because they're walking up and down hills all day. So it would be really useful, I think, to have not necessarily an external guidance that states this is what you must do, but provides examples on what different levels of intensity of sampling can provide in terms of information and confidence in the results, to try and help funders, in this case government, because as well as private, know what they'll get for what they're asking, because that's our biggest challenge. We're sort of just adapting our strategy that we developed internally, which would suit our needs to fit these external projects. And yeah, we hope it's what they want and that they don't reflect back in 5 years ago, why'd you do that? But yeah. And we are also sort of around the challenge starting to look at modelling. We're talking to people like Downforce Technologies and others who can remote model soil carbon to try and work out how can we combine perhaps more strategic sampling with external modelling to try and reduce the actual cost of physical sampling. And that's it. Thank you.
Thanks so much, Felicity. That was brilliant. I mean, I think that's also a really, really important question. We're not always talking about farmland here. More and more we're seeing interest in nature recovery. So, you know, these kind of landscape scale projects and the way that we think about, you know, indicators outside of farming systems is also just as much of a challenge, and really pertinent to this question of soil carbon, because you know, there's so many opportunities there, but also so much to clarify. So thanks very much, Felicity. It was fabulous. I'm going to pass over to John Gilliland. Now, John has got a kind of two parts, sort of three parts, haven't you, John, to what you're doing, because we're going to hear about what John's done more within his own projects, then the Northern Irish picture, which is, you know, famous, but with little detail behind it. As far as I'm concerned, I'm always hearing about it. I heard at Welsh Parliament recently, it's kind of put forward as a real exemplar, but actually people don't know very much about what goes on, as Tom said, under the bonnet. And then also John is kindly going to cover what's going on with the AHDB baselining project, because John's been instrumental in designing that as well. So over to you, John.
Thank you very much, Shelley, and thank you, Lunds, for the opportunity to share really what is the last 10 or 11 years of my journey of investigation. So very similar to Tom's regards, we've been on a journey and we go off and do one thing and then we see bit of that work, but we could do it better. How do we do it better? So really the image on my lead here is our experience starting with augering, right through then to how we fully automated it and put quality control into it. So next slide, please. So really for me, when I am asked by various people about soil carbon baselining, the very first question I ask back is why? What is the context? What is it that you're looking to achieve? And really, I want to highlight over the last 11 years of my experience that the why that I was being asked for were different. And it's really important when you go on this journey, you contextualize why are you doing this? And I think really the catalyst for my journey was when the Permanent Secretary in Belfast asked me to construct an expert working group in 2014 and write Northern Ireland's first sustainable land management strategy, otherwise known as SAMS. And we came to this from a different angle. Our real key issue out there was around water quality. Most of you will know Lough Neagh is now fully eutrophic. You know, what is the role of land and land's runoff from that into the water quality? Around that then, what was the issue of productivity of that agricultural land? And for the last 40 years, we have had a real absence of spreading lime, so soil pH had collapsed. And looking to correct that soil pH, recognizing the last thing we need is a heap of lime going on organic soils. So where are those organic soils? And really, our journey to starting to look at soil organic carbon was actually from the approach of protecting highly organic soils from excessive liming and mineralizing that carbon. Next slide, please. And, you know, beyond that, as the farmers I work with in the Arc Zero network, they are on a journey of of conversion from a monoculture perennial ryegrass with a lot of synthetic nitrogen, cross to certainly looking at herbal lays, multi-species swards, and with that increasing plant diversity going in, getting a more dynamic root architecture and actually being able to measure the consequence of change in the soil. Alongside that, in the last 4 years, we have really started to see the consequences of extreme weather events. Our climate has already changed, and land managers wanting to understand how do they build better resilience of their soils and the role that soil carbon plays in building resilience. On top of that, then, the role of, where I predominantly come, it's livestock agriculture. We are being beaten up in emissions, but nobody recognizes that our landscape also are custodians of great amount of carbon. So actually, on a reputational issue, what is it that we are custodians of? How much? Where? How do we influence it? And that became one of our big drivers, was reputation. But to top that off, Tom has already talked about the challenges of the emerging land sector removal guidance through into Scope 3. But the issue nobody's talked about yet is currently the UK's National Greenhouse Gas Inventory, LULUCF, does not recognise soil carbon, does not recognise soil hedges, silver pasture, farm woodland. And we wanted to create the evidence base, not just for the private sector, but for the public sector, so that we could actually get DESNEV to move and actually bring in nature-based carbon removal solutions into the Greenhouse Gas National Inventory in the LULUCF. And the last thing, and so we know in England, we have a land use framework consultation just finished, is this whole issue, what is the impact of long-term land use change? So for me, when you go on this, you really need to ask and answer these questions before you start. Why are you doing it? What is it you're looking to achieve? Next slide, please. So I mentioned earlier on that I had the privilege of chairing the expert working group that wrote the Sustainable Land Management Strategy in Northern Ireland. We published it in 2016. And our key message out of that, and interesting, I was in with Dear only last week, and there was recognition that our recommendations in 2016 are as valued today as it were then. If you cannot measure accurately, how can you manage that soil properly? And this, more than anything else, should be a feedback loop for land managers, for decision makers within land management. First and foremost, before you are blinkered and blinded about monetizing it. This is about knowledge, a knowledge-based journey about making land managers better land managers. That key for us in that journey was improving water quality, creating runoff risk maps, okay, not in the soil, but we did, we advocated introducing the LiDAR technology and actually mirroring that across. Our key issue was how do we mine the surplus phosphate that is in Northern Ireland soils? How do we use that to improve grass utilization? But do that in a way that we protect our special organic soils. And so we recommended that you measure every field, tree and hedge in Northern Ireland. But key in that is that you measured soil organic matter, certainly in the top layers, so that we could adjust our lime recommendation to make sure we weren't mineralizing carbon on organic soils. Next slide, please. As a consequence of this work, the Soil Nutrient Health Scheme was launched in 2021, and it is not doing deep soil organic carbon measurements in its main. There is a pilot, and I know Alex Higgins is on the call, and Alex is far better capable of answering those questions. But in the soil analysis, it was 25 cores per field. Our fields on average are somewhere around 3 to 4 hectares. We were sampling to 7.5 centimeters in grassland and 15 centimeters in arable. Next slide, please. I then moved on to Arc Zero. Arc Zero is an EIP operational group funded through DERA. It's a group of 7 farms, including my own, going on a journey towards net zero. And our main motto, again, if you can't measure, you can't manage. We need the baseline. We need to know what we've got. And we want to get some understanding of the impact on our soil organic carbon levels under different land uses and under different managements. So we did a huge initial stratification, and you can see how we stratified across there. We stratified on different organic matters, we stratified at different land uses, on whether organic manures were applied. Was it grassland? Was it permanent rotational? If it's rotational, was it perennial ryegrass, multi-species? In the case of woodland, was it deciduous, coniferous, short rotation willow, silver pasture, whatever? Next slide, please. And in trying to work out the sampling densities, and this was back in 2021, 2022, we biased the sampling densities to the soil categorizations that were small, because we basically wanted enough statistical power in our results to be able to draw some kind of conclusions between the categorizations. We ended up with 86 different land categories. And key in this was also understanding our soil texture classification, which we did. All of this was done through the services of RPS, who lifted the soils independently of us, and NRM, who did the actual analysis. Next slide, please. And I'm just highlighting this. You don't need to look at all, but this is one example. Hugh Harbison's dairy farm. And you can see in his case the number of different categories he's got, the acreage, what was the loss of ignition results, the number of cores, number of samples, 0 to 10 centimeters, 0 to 30 centimeters. And you can see the variation there. And from that, we were able to put some kind of figure, how much carbon were in his soils in the top 30 centimeters. Next slide, please. And we did that over the 7 farms. And we also added alongside that, for the first time, the results of the great bit of work that Alex Higgins and his teams and AFBI did for us, which was to analyze our LiDAR data to measure above ground carbon too. So we were able to get, for the first time, some understanding of the total carbon stocks, both in the soil, in the trees, across the 7 farms. I think if someone had said to us when we started this project, there was over 500,000 tonnes of carbon in these 7 landscapes, I would have said rubbish. Well, that's what we found. And interestingly, now the caveat is it depends on the algorithm you use to convert LiDAR into volume into biomass. But using the IPCC algorithm at the moment, we are finding on these farms 97% of the carbon is in the soil and not in the trees. And even on my own farm, which is heavily wooded, 80% of the carbon is in the soil. And it does frustrate me that in policy, everyone's out scrambling around trees are the answer, trees the answer. Well, if we want to look after what we've got, it's in the soil first. Next slide, please. But it's really important that you learn as you go along. And I have a health warning here. In the first stage of our work, we measured bulk density in 2 totally different ways. One way is we took our core, we cored out and we sent it to NRM, and they did an in-lab situ fine bulk density. On the other hand, we did it the old-fashioned way. We took a cylinder, we sledged it into the ground, we dug down around it, and I have to say, when we went to do a comparison on the 2 bulk density methodologies, there was very little comparison, I have to say, and really got us worried. Everyone wants to measure soil organic carbon stocks, but to do that, regardless of how good your soil organic carbon percentage is, if you have not got an accurate bulk density method of doing this, then actually your soil tonnages cannot be accurate enough. Next slide, please. So for us, we wanted to move on. Just like Tom wanted to move on, we wanted to get a quality controlled process. We wanted to go down to a meter, particularly as we wanted to look at the consequences of different long-term uses. My own farm is absolutely part of the Arc Zero farm. We have 5 historically different long-term land uses, from willow, deciduous woodland that's 30 years old, silver pasture 120 years old, deciduous woodland 250 years old, and permanent grass that's 200 years old. And we really wanted to get an understanding of what were the impacts of different land uses over long terms. And that was where we decided we wanted to upskill or have a better service in how we sampled. And that's when we switched to the services of AgriCarbon. This piece of work was done by a Wagram master's student. And I'll just show you another two slides here. Next slide, please. And key in that was understanding when you go on this journey, you absolutely do need to know your soil texture classification. You have to understand, are you comparing apples to apples, orange, pears? And what you can see then is the total soil organic carbon stocks as an average across my 5 different land uses. 3 are statistically the same. There's one clear winner, and there's an oddball in there in the willow, because the willow, 30 years willow, went into my arable land that had been arable rotation for 30 years. And certainly we've seen quite an extraordinary turnaround from 30 years of arable through our willow. Just to give you an understanding of the sampling density we used in this, and Helena was very much had her hand on this and helping me give me statistical power. In this case, we were doing just over 17 samples per hectare. And I personally paid for this as part of the ArcZero work to really give us a fantastic data set of the long-term consequences of different land uses on a similar soil type. Next slide, please. And the beauty about what the service we now get from AgriCarbon is the fact they stratify it at depth. You get 0 to 15, 15 to 30, 30 to 60, 60 to 100. And you can see on the graph there where we've actually plotted soil organic carbon against depth, against each of those land uses. And you can really see the benefit of bringing woody species into the grazing landscape there. If I look at the 30 centimeters, the 2 highest, the blue is silver pasture, the purple is willow, really seeing the benefit. And the great thing, when we repeat this in 5 years' time, we will be able to see how our interventions in the meantime actually move the dial. Next slide, please. So that takes me on.
John, sorry, I'm just going to jump in very quickly because there's so much to learn from the experiences of the speakers here today. Tom, there's a question for you in the chat, and we're probably going to eat into some of the Q&A session because we want to hear all of these examples, which are so useful. So please do use the chat, and speakers do look out in the chat for any questions that are for you. So yeah, over to you, John.
So that then took me to a request from both AHDB and Quality Meat Scotland. Could we help in looking at doing something similar, but doing it at a scale? Because one of the things we've all said, and Helena very helpfully showed it, that if you start to do it at scale, you get so much more statistical power at a lower sampling density as such. So levy pairs in England, Wales and Scotland have contributed £3 million to a scheme looking to baseline 36,000 hectares on 170 farms, 4 different sectors. So it's the red meat sector, dairy, pig meat and cereals and oilseeds. And you can see the geographic spread from certainly from Cornwall right up to John O'Groats there. Next slide, please. And really what we're trying to do here is not just measure carbon, but actually recognize, because both the levy boards, AHDB and QMS, have a role around reputation as such, and actually explaining to wider society and politicians and policymakers what is it that's going on out there, and having a really good granular data set that we can use for reputational. The second thing was, for the first time, to really start get an understanding of the scale of carbon stocks out there as a baseline, with the hope that we can repeat it in 5 years' time and start to measure change. And the third thing is to position then where UK agriculture is against some of its peers internationally. Next slide, please. And what is it doing? It's a combination of soil measurement, aerial LiDAR, and also putting all the farms through a carbon calculator. And what we're trying to do is look at a whole systems approach of how we go on a journey to net zero, looking at carbon removals, looking at mitigation, looking at how we get behavioral change, but creating knowledge back to individual decision makers on farm to allow them to make better quality decisions and build resilience. Next slide, please. So in the soil sampling, just to put a bit of, we are doing just as we did on my own farm. We're measuring at 4 different depths in the farmland, in the woodland where we can get access because it's not so easy, and particularly after the storms. We're doing 3 depths there. Our sampling density over the 36,000 hectares is between 1.25 to 1.65 cores per hectare. On moorlands, we're only doing basically a sample every 2 hectares. We are also measuring soil nutrients, pH, texture at 0 to 15. And the sampling is ongoing as we speak at the moment. Next slide, please. I said earlier on that this is part of a package. In parallel to this, those farmers are going to go through a carbon audit, carbon calculator with consultancy. So year 1, year 3, year 5, those consultants have now been picked. ADAS is doing it in England and Wales. SRUC are doing it in Scotland. And we will be embedding in the results of the LiDAR in there for the above ground biomass and also runoff risk maps and looking at delivering on water quality as well. Next slide, please. Our key other elements is we have, and we're very grateful that DEFRA is giving us a bit of support. Our key focus here is to prove to society and to government, if you empower land managers with really good data, with training, they improve their behavior. So this is a story about behavioral change. We are not ignoring soil biology. We just haven't bottomed out exactly what soil biology metrics we're going to do. And also we will flirt with remote sensing to see, is there some way to look at about taking costs out of this in the medium term. My own farm has just been remote censored as well, and we're just going through the compare and contrast at the moment. Next slide, please. So in conclusion, for me, around soil carbon baselining, the key thing I would ask when anyone asks me for my opinion is, why do you want to do it? What is the context you're trying to answer? And there's a collection of questions you need to ask yourself. And these were the questions certainly that we have posed and we are trying to answer at the moment. Next slide. And I'm just going to leave you with this comment. If you cannot measure accurately or with granularity, you will never be able to manage that soil properly. And ultimately, what we need is behavioral change, not more rules and regulations. This has to be a knowledge-based journey. Thank you very much.
Thanks so much, John. That was brilliant, and really good to see those 3 different contexts and actually how you've applied the same kind of thinking across the 3 of them, which is, where we want to get to essentially, isn't it? I'm sure there can be lots of questions for you also. I'm going to pass over now to Will in the interest of time. And Will has something specific to offer, which is also this idea of sort of taking a step back and looking at this question of purpose, as well as having specific projects on the ground to take us through. So over to you, Will.
Excellent. Thank you very much, Ellie. Yeah, so I'm representing a team here at University of Plymouth, an interdisciplinary team spanning land and water process, ecology, biology, human geography and technology. And we're really interested in that sort of more holistic look at soil health. And I want to share with you a case study in the Southwest that's ongoing, that sort of ties into a lot of the issues raised today. So if we could go to the next slide, please. So in terms of purpose, we set this particular study up in collaboration with an agribusiness that was moving into regenerative practice. And their ambition was to build up evidence that would sort of tell the public, their consumers, the story of their journey on the regenerative practice pathway, not just about carbon, but about the sort of the wider co-benefits of soil health that John just alluded to. So very much interested in the broader environmental gain versus the agribusiness sustainability. So it's a very sort of broad remit. And in parallel for us as a research institution, as a university, we're really keen to use this as a basis for some kind of a living lab, which would support our future agri-research process questions, postgraduate training, and so on. But especially from our point of view, a sort of research furrow that we're ploughing in terms of agri-tech and sensor-based data acquisition that can be potentially in the future farmer-led. So it's quite a broad remit to this particular study. Next slide, please. So give you a bit of a sense of the overall experimental design, and then just dive a little bit into the sampling and things that we've learned so far, but very much work in progress. So overall, this is an estate that was formerly in various tenanted component parts. It's just all been brought back into one piece. There's three key farming units within the estate. The central part, which you can see in purple there, is still within tenant farming, and it's going to maintain business as usual in terms of dairy, beef, and mixed arable production. And then in the north, the farm is going to go into a mob grazing regenerative practice on pasture, lay and permanent pasture. And in the south, there's going to be herbal lays established. And so the landowner was really keen to get a sense of where the land was at now, and then to think about how that could then be used as a baseline to monitor trajectories of change. So we looked at those three sort of key areas, the sort of the business as usual, the moving into sort of really carefully managed mob grazing, and then moving into herbal lays. We looked at those as three sort of different intervention areas as a broader experimental design. And then within there, of course, we've got field parcels. And the idea was to sample at 0 to 10 centimeters to try and capture short-term changes, particularly in terms of the sort of the microbiology that I'll come on to later on. But also then to think about the deeper level to try and comply with broader recommendations. So again, trying to sort of fit many different agendas here, but driven by what the landowner really needed. And then we did various sort of profilings in terms of bulk density and collected aggregate stability, and looked at infiltration at a slightly more sort of less extensive scale than the sampling. I'll come on in a minute to exactly what we measured. Tried to focus around spring in terms of sampling, and the idea is that we'll resample subject to funding in the future. But this study was really about establishing that baseline and sort of future-proofing what we do at the university, and hopefully through postgraduate research, keeping this extending on. Next slide, please. So the sample design itself, you can probably see on the map there, we've got lots of dots on the map where the samples were taken. The way we went about deciding where to put these samples was based on a GIS model, which we used. It was based on LiDAR, a DEM based on LiDAR. And then we essentially produced strata within the different land use interventions based on aspect, elevation, and the wetness index, which was a proxy for slope. So we're very mindful that in these hilly South Devon landscapes, we have a lot of variability within any particular field, let alone within one particular land use. This is all on the Dartmouth slates. It's quite shallow soils. So as I said, we went 10 centimeters and 30 centimeters where possible. Sometimes the soils are shallower than that. And the idea was to get 30 samples, thinking statistically between 30 samples from each of the interventions for comparison, and then to get a minimum of 10 per stratum within, as defined by the GIS model. But what we also did was ensure that there was a minimum of one sample per field, because from an agribusiness point of view, the farmer was really keen, landowner was really keen to know how each field would be behaving in the future. They've got a lot of ambition to sort of experiment within those zones. And so the idea was to make sure we had very good coverage across the piece. Each of the sample points, we hired a team with a drilling rig, similar to what we've seen before. So that was they were drilled automatically. So every sample taken was a composite of 25 individual cores, and everything's georeferenced. So yeah, I think the FAO, if we go to the next slide, actually, we'll look at the protocols we followed later on. So yeah, holistic. We weren't just looking at carbon. Full range of things listed here, which I won't read out. We sent samples out to Landcrop for many of the measurements taken. This was again thinking about the agribusiness needs. We wanted to make sure we were working with an accredited lab, which could then, so those data would be of use to the agribusiness we were working with. But then, of course, other things were done within our own labs as well, which are starred up there. And I think the key thing at the add-on part, and I'll come on to this at the end, was our ambition to explore how sensor technology can help bridge the gap between some of the questions about representativeness and coverage. But yeah, we took a holistic approach, not just carbon. Next slide, please. So in terms of protocols and standards, I've alluded to this. So we followed the GSOC protocol in terms of defining those strata. We're also heavily influenced by Helena's and team's review as well. Really useful to sort of understand where the different challenges are. Think about future proofing, and obviously that's the purpose of being here today is to share experiences. So I think those two pieces were really important to us. But the other really important thing, and this is thinking about the interdisciplinary approach that we favour here at Plymouth, is that we were steered strongly by the farmer knowledge and also the agribusiness needs. And again, this reflects what people have said already. Working with the social scientists, using social science methods to really understand what was already known and to help use that to help steer where we drilled in the ground to get quantitative evidence, so we could fuse that with the implicit and sort of long-term knowledge of the land that was in the farming community. Next slide, please. So we've got some example results here. These are, I'll call them preliminary because we've got to really get to grips with some of the variability ourselves. But I think the really important thing about these maps that we can see here, which are organic carbon from the northern and the southern portions, the areas that are going into regen practice, is that there's a huge amount of variability, even though these particular components of the land have been in what you might call the same kind of land management practice in the past. Some of that variability is, I guess, due to natural factors. A lot of it is because there's been a very mixed sort of management regime by different tenants, and so you can find little slithers of land that are in a very different state to other slithers of land, and that's because in the 90s, early 2000s, a different farmer was working there with different input regimes and so on. So we've got very, very high variability in terms of the background context, which is important in terms of course, sample representativeness. We had the opportunity here to take a lot of samples in a very small space of land, and it's sort of thrown up this important point that baselines are highly variable and dynamic in their own right. And so we're trying to get to grips a little bit with that, again, through talking with the local landowners, and also we've got to do a deep dive into the data to understand the different interrelationships between that wide range of soil properties that we've measured. But I guess it really underscores that importance of local knowledge, working with the people who understand the land better than us as scientists coming in, the importance of the sample stratification, the data structure, and really understanding what we're dealing with. And then I guess the other thing in this study is we're really keen to make sure we've got a meaningful control. And so we're lucky that we've got that business as usual operation going on in the middle of this area, and we've got these two different interventions, north and south. So the idea is, in terms of our long-term monitoring ambition here, which is of course subject to funding, is that we've got something really robust to move forward. So what we see as we progress through the future is going to be meaningful and something we can talk about. Okay, next slide, please. So the wider points, Ellie, that you'd raised in terms of what we sort of, what we think and what we're learning about this, I think we've, and Helena started with this point, and me and the team fully aligned to that. It's not one size fits all. And quite often we're asked when we talk to landowners about, doing sampling and studies together, is this right? Is this design that we've laid out right? For us, it's very much about, well, is it actually defendable? Is it fit for purpose? Again, reflecting what John had said, so really understanding what we're in this for. And I guess in this study, we took quite an inductive approach because we're kind of measuring everything under the sun because we want to really understand the broad holistic narrative of change. But yeah, fully agree with what's been said to date, is that really understanding what we want from the data is absolutely fundamental. And then, of course, we have the constraints that others have outlined in terms of resource. And so I guess, yeah, we want to be led by the questions, and those questions tend to be for us within the sector itself rather than within our academic world. In terms of what we would advise moving forward, and this is going to be a bit of a plug for what we're doing in terms of our sensor technology, but there are ways in which we think we can close some of those logistical challenges in terms of sample representativeness through sensor technology, and I'll talk about that in the last slide. So there's an angle there in terms of new technology. We've talked a little bit about remote sensing. What we're talking about is something that's sort of a little bit closer to the ground, but still passive in terms of its assessment for mapping. And then the other key point for us is being aware of the agribusiness needs, and I think we really need to be thinking about putting that local farmer knowledge, or in a sort of global south context where we do a lot of work as well, indigenous knowledge, thinking about that and the practitioner know-how. That's got to be on a level playing field with the quantitative evidence that we bring in from the science side. And so the role of social science in this is really fundamental, that fusion across disciplines in terms of getting a holistic view of what's happening. So you can see the team there, social scientists, we're doing some work at the moment evaluating farmer-led methods. And we think the technology that we're working on might be something that, again, bridges that gap and empowers farmers to maybe be more in charge, in control of collecting the data themselves. So if we go to the last slide, which is sort of looking forward into what we're doing within the LUNS project. Ellie mentioned that we're participants in one of the LUNS research projects. So this is a collaboration with University of East Anglia, who are the lead organisation. The project falls into two halves. There's a modelling component and then there's a soils component. So Brian Reed, who's in the audience today, is heading up the soils component, and it kind of goes in interesting directions in terms of what we're doing with the soil. There's a deep dive into the soil quality, the soil carbon quality, and its relationship to the microbiome and so on. So that's sort of where University of East Anglia are focusing. Then on our side, we're thinking about how do we then put those really detailed evidence bases of soil behavior into context, and that's where the mapping with the sensor technology comes in. So really briefly, you can see in the left-hand side, top left-hand side there, the map of radioisotopic signals within the soil that correlate inversely with organic matter. And what's happening is the gamma detector you can see on the right is picking up signals from the mineralogy of the soil. Those signals are perturbed by organic matter and moisture. And those, if we can understand the signal relationship between the SSE under the full range of conditions that we might encounter, we have something that's close to a quantitative mapping tool of soil properties. And so what we're really working on hard at the moment is validating those signals. And that's our component part of the Land Use for Net Zero program, working with University of East Anglia. I would say, I guess this is thinking at the bottom right, this is part of a wider intergovernmental ambition for nuclear tools and techniques. So as well as working within the UKRI framework, we also work with the International Atomic Energy Agency on these tools. And our ambition is that if we can prove and validate these, then they can become part of the toolkit, which helps us bridge those different scales that we've been talking about today. Okay, thank you very much.
Thanks so much, Will. That was brilliant. And I think that last point's really important. This question of this kind of empowerment, the social aspect, high tech, hard science, data, but also, that actually, how people are actually empowered on the ground. I think if you're at Yeo Valley, you talk about having a nice time enjoying it. But that's also so important part of this whole picture. Over to Matt and see if you can squeeze something out the last 5 minutes in terms of questions, where we've got these brilliant speakers here.
Thanks, Ellie. We've only got a couple of minutes, so I think most of the questions have actually been answered in the chat, but one I quite like to focus on is one that Helena responded to, which is about what approach you take to variability, both in terms of seasonal carbon stock dynamics and also across a rotation. So if you could give us an answer to that in about 2 minutes, if possible.
Who, me?
Yeah.
Oh, you must be joking. I have to say, if I was going to focus on any area that I'd really wish the scientific community could help us on, it is the rotational dynamics and soil carbon stocks, because we're really going to have to crack that one to help Scope 3 reporting. All I can say is, at the moment, what we're trying to do is generate data sets to try and get a better handle on this. You're after a sampling strategy that effectively detects a signal over noise. So there are ways to design a sampling strategy that can account for it. But if we don't know what it is, it's quite difficult to accommodate. And there are relatively few data on soil carbon stocks and rotations. There's a lot about SOC%, but that doesn't necessarily affect the stock monitoring. I'm going to leave it at that, because it is a real headache for me.
Thanks very much, Helena. I'm certainly not going to try and summarize because there was a huge amount of detail, and we're going to be uploading the slides and the full presentation in due course. Instead, I'm just going to list a couple of points that jumped out to me while listening about next steps, both for the Lunds Hub source tag and also, with our SSA hat on. These events always pose more questions than they ask, which I think is very helpful in terms of our kind of trajectory. I think the first point is really around the need and appetite and potential standardization, because we've heard that, from across all speakers, that there is, on the whole, a lack of a clear top-down vision from funders, from authorities, etc., about what exactly a high protocol sampling strategy is. Will referred to GSOC, Helena referred to the Vera handbook, Tom referred to the land sector removals guidance. All of these are international, and I do wonder to what extent there is a need and an appetite for authorities at national level to have, as it were, bridge the gap between these kind of high level pieces of policy and what happens at field level and at corporate level. And I think that's something that we'd like to explore. The second thing I picked up on was really around sort of the evidence gaps in all this. It's a critical role for the Lunds Hub is identifying evidence gaps and looking for opportunities to bridge them. Two jumped out in particular. Number one is the evidence base for regenerative farming, and Helena pointed out the real challenge of rotational systems and what the evidence base is for that. I think we would add to that in terms of the evidence gaps that we identify, that while we see a lot of evidence around individual actions for regenerative farming, where there is a gap is around these actions in combination. So when you do lots of things at once and what impact that has on carbon diversity, etc. And then Tom also talked about the evidence base around connection between soil carbon and biogenic carbon fluxes. So Tom, it'd be great to get more detail from you on that. And then the other thing that came up a few times was the role of models in all this. Models sit alongside sampling strategies as being, the other part of the picture here. And again, it'd be really helpful to dig into that and understand how the hub can support understanding on that. Where are the uncertainties? How measurement and modeling can be combined? To what extent are the models available, currently applicable for what happens in the UK? So those are three things that I think I picked up on, but please do share with us other thoughts, other areas that you would like to see the Lunds Hub pursue in future. Ellie, back to you.
Thanks, Matt. Yeah, brilliant. So we are just a tiny bit over time, which is a miracle, because there's so much content here, and I'm really glad we didn't have to rush it. Huge thanks to our brilliant speakers for joining, for contributing so generously. Thanks to everybody who's participated with questions. Do keep them coming. Zach, if you can just pop an email in the chat, anybody who wants to reach out with questions for the Lunds Hub for the soil tag, please do. Or with suggestions of areas where you would really like to see us, generate activity, look into things, bring people together, etc. So yeah, we look forward to continuing the conversation. Thanks again, and until next time.
Thanks, Ellie. Thanks, everybody. That was very good.
Thanks all.
Thank you.
Thanks, everyone.